Welcome back to another lesson in MCR3U. Today we'll be talking about multiplying and dividing rational expressions. So we'll start with a couple of warm-up questions here. And so these are just simply multiplying two fractions together. So when we're multiplying two fractions together, we are simply multiplying the numerator with each other and the denominator with each other. So here we have 2 over 3 times 5 over 7, which will give us 10 over 21. And that's for multiplying 2 times 5 and 3 times 7. Here, if you recall, if we have something that is a division statement, we can convert it to a multiplication statement by flipping the second fraction. So here we can rewrite this as 2 over 3 times 7 over 5. So now we can treat it like any other multiplication statement. So 2 times 7 will be 14. And 5 times 3 will be 15. And so this last one here, we have 2 over 3 times 6 over 7. First thing we can do is we can see if we can simplify or cancel out some of these values in these fractions. So 6 and 3 can be simplified to 2 and 1. Remember, you can only cancel out these values if it is multiplying. If there is addition or subtraction symbol in between, then you cannot cancel these values out. So here we have 2 times 2, which will give us 4 over 1 times 7, which is 7. So our final answer is 4 over 7. So let's start with this case here. So it says simplify and state any restrictions. So again, our restrictions come from the denominator. So here, if we write our restrictions, there are values which make the denominator equal to 0. So here, x cannot be equal to 4, and x cannot equal to plus or minus 5. And if we look at this multiplication statement, there's a few things we can cancel out. So x plus 5 we can cancel out. X minus 4 we can cancel out. And these, and also with the coefficients here, 2 and 8 can cancel out. And 15 and 5 can cancel out or be simplified. So here, this will be 1, this will be 1, this will be 3, and this will be 4. So here, if we rewrite the expression now, it will be 3 bracket x plus 4 over 4 bracket x minus 5. Okay, so let's look at a little bit more complex rational expressions here where we're going to multiply. And so it says, again, simplify and state any restrictions. So here we see that x squared minus 9 is going to be a difference of squares. And so the first step we want to do here is, again, factor anything that we can from the numerator and denominator. So here we get x minus 3, x plus 3 over, and here we can factor out a common factor of 2. We're left with x plus 2, multiply that by x plus 2 over x plus 3. So here we see that we have few restrictions. So our restrictions are x. So restrictions are x cannot be equal to -2 and -3. Now we can cancel these out, x plus 2, x plus 2, x plus 3, x plus 3. So here we're left with x minus 3 over 2 as our final answer. And we can actually get rid of these brackets here. Okay, let's look at b here. So here's x squared minus x minus 20. So a simple trinomial, factor that out, get x minus 5, x plus 4 over another simple trinomial, x squared minus 4x minus 12, which will give us x minus 6, x plus 2, and we're multiplying that by x plus 2 over x plus 4. Okay, so we can state some of our restrictions here. So with our restrictions, x cannot be equal to 6, -2, or -4. Now we can cancel out x plus 4, x plus 4, and x plus 2, x plus 2. So here we'll be left with x minus 5 over x minus 6. Okay, so if we look at the three steps that we take to simplify and state any restrictions for these rational expressions that are being multiplied, the first step is to factor the numerator and the denominator. So the first step is to factor the numerator denominator. The second step is to state the restrictions in the denominator. And then the last step is to just simplify the expression. Okay, so let's look at dividing rational expressions. So same thing that we're doing here. We are going to simplify and state any restrictions. So first thing we want to do is we want to factor out the numerator and denominator. So same thing that we did before. So again, another simple trinomial, x minus 5, x plus 4. Into denominator, we can factor out an x. We'll be left with x minus 5. And then two simple trinomials here. You can simplify as x plus 5, x plus 4, and divided by x minus 6 squared, as that's a perfect square trinomial. Okay, so the first thing we want to do here is we want to state the restrictions before we flip the division to multiplication and we flip the fraction. And so here we can indicate that our restrictions, x cannot be equal to 0, 5, or 6. And so here, before we flip the fraction and convert this division statement into a multiplication statement, we want to state the restrictions. So now we'll switch the numerator and denominator and make this a multiplication statement. So here we have x minus 5, x plus 4. This stays the same over x minus 5. And now we're going to multiply by x minus 6 squared over x plus 5, x plus 4. And now we can, as we look at this, now there's a different denominator in this in the second term. And now we have to state those restrictions as well, because they are different than what we just stated before. So we also know here that x cannot be equal to -5 or -4. And this is because, again, the numerator became the denominator. Okay, then we can start canceling things out. So again, x plus 4, x plus 4, x minus 5, x minus 5. So we'll be left with x minus 6 squared over x times x plus 5. Okay, so let's look at this next example. So we have x squared minus 2x minus 15, sorry, x squared minus 14x plus 49 over x squared plus 4x minus 32 divided by x squared minus 3x minus 28 over x squared minus 4x. If you noticed, when we're looking at the previous expression, the restrictions are really just the denominator from the first term, and then both the numerator and the denominator in the second term. And these are our restrictions because we're going to flip the numerator and the denominator to make it a multiplication statement. So here we have a perfect square trinomial with x squared minus 14x plus 49. So that will give us x minus 7 squared. Simplify the simple trinomial, give us x plus 8, x minus 4, divided by factor, again, x squared minus 3x minus 28, give you x minus 7, x plus 4, and factor the common factor of x, and we'll be left with x minus 4. So again, we can see that our restrictions are going to be the denominator from the first term, or the first fraction, and then also the numerator and the denominator in the second term or second fraction. So here our restrictions will be x cannot equal to -8, 4, 7, -4, and 0. So you can do this all in one step, or if you prefer, you can list the restrictions here first of -8, 4, 0, and 4. And then once you flip it into a multiplication statement, then you can list the last two, which would be 7 and -4 as well. So here, we're going to convert it to multiplication statement. So we have x minus 7 squared over x plus 8, x minus 4, multiply, flip numerator and denominator, x bracket x minus 4 over x minus 7, x plus 4. Here we'll cancel some things out. So here we have 1x minus 7, x minus 4 cancels out as well. Here we'll be left with x bracket x minus 7 over x plus 8 plus 4. That's going to be fully simplified there. Okay, so here again it says multiply or divide simply as much as possible, or simplify as much as possible, and state all restrictions. So here, factor, we get x plus 5, x minus 3 over x minus 4, minus 3 times x minus 4 over x plus 5. So here we can state our restrictions. X cannot be equal to 4, 3, and 5. 4, 3, and -5 here. And we can start canceling some things out. So here, see that x plus 5 cancels out, x minus 3 will cancel out, and x minus 4 will cancel out. So for this expression, the answer is equal to 1. Okay, let's look here. So here we have 7y squared divided by 7 squared minus 9. And that's a difference of squares here. So here we'll factor 7y squared over y minus 3, y plus 3, divided by 14, y to the power of 3, over factor a common factor of 4, and we'll be left with y plus 3. Okay, so let's state our restrictions here. Y cannot be equal to 3, -3, so plus or minus 3, and y cannot be equal to 0, which we see from the numerator in the second fraction here. So now we'll flip the fraction. So here we'll have 4y plus 3 over 14y cubed. And now we can simplify some things here. So here at the 7 and 14, we can simplify that. So that'll be left with 2. Y plus 3, we can cancel that out as well. And our final answer will be 2 over, so 4 divided by 2, which gives us 2, over y times y minus 3. Okay, so just two more examples here. So a little bit more complex ones again. So here we have x squared plus 3xy over x squared minus xy minus 42y squared times x squared minus 10xy plus 21y squared over x squared minus 9y squared. So here at the top, you can factor out an x. You're left with x plus 3y. On the bottom, here if we factor this out, factor out x minus 7y, x plus 6y. So again, it's the same as any other simple trinomial, except in this situation, again, you're going to add this y value here as well. And then we're going to multiply. Again, here, x squared minus 10xy plus 21y squared. So here we'll get x minus 7y, x minus 3y. And then here, this is a difference of squares at the bottom. So that's going to give us x minus 3y, x plus 3y. Now we can cancel some things out after we state our restrictions. So here, as we see that there's two variables, we can just state it in terms of one variable or x here. So x here cannot be equal to 7y. X cannot be equal to negative 6y. X can not be equal to 3y. And x cannot be equal to negative 3y. So those are our restrictions there. So now we can cancel some values out. Here we can cancel out x plus 3y, x minus 7y, and x minus 3y here as well. And so we'll be left with x over x plus 6y. Okay, and let's look at this last expression here. So here you see that 9s squared plus 30st plus 25t squared, that's a perfect square trinomial. So Here, perfect square trinomial, you see that that's going to give us 3s plus s squared. So 3s, sorry, plus st squared, bottom of 25s squared minus 25st minus 6t squared. So again, same idea in terms of any other complex trinomial. Here, you'll get 5s plus t and 5s minus 6t. And we're going to divide. Then we'll factor out the other side, which is going to be 3s plus 5t times 4s minus 5t over 5s minus 6t times 4s minus 5t. Okay, so let's state the restrictions here. So if we state the restrictions, we'll have 5s plus t cannot be equal to 0. And then we can rearrange it so it is just for s. So here, s cannot be equal to negative t over 5. That'd be one restriction. Second restriction, we have 5s minus 6t cannot be equal to 0. So here, 5s cannot be equal to 6t, or s cannot be equal to 6t over 5. So any of those work in terms of how you write it. Third here, we have we have 3s plus 5t, again, cannot be equal to 0. 3s cannot be equal to negative 5t, and s cannot be equal to negative 5t over 3. And then here, the last one here, we have 4s minus 5t cannot be equal to 0. So here we have 4s cannot be equal to 5t, and s cannot be equal to 5t over 4. Okay, so if we rewrite this expression as 3s plus 5t squared over 5s plus t, 5s minus 6t, and then change it to a multiplication statement. So we'll flip the fraction. So 5s minus 6t, 4s minus 5t over 3s plus 5t, 4s minus 5t. So here we can cancel a few things out. So 3s plus 5t, 5s minus 6t, and the 4s minus 5t here. So our final answer will be 3s plus 5t over 5s plus